All right. Well, look, thank you for making the time to come to today's presentation. I'm going to be talking a bit further about Synapse SQL Serverless and some of the performance optimizations that you can be doing with that. So if you've got questions, you can ask them on the Slack. You can use the bit.ly link down the bottom to ask them for not just my session, but all the sessions. And if I don't get time to answer them, I'll come back to them. So let's jump in. So who am I? I'm a data and AI cloud solution architect at Microsoft in Dublin. I'm originally Australian, moved to sunny Ireland 18 months ago because that seemed like a really good idea at the time. Hindsight, maybe not so great. You can find me on LinkedIn, you can find me at Twitter. The most important part of this slide is that these are not necessarily the views of Microsoft, yada, yada, yada. So that's the important takeaway. So let's take a little bit of a story about like what is Synapse SQL Serverless, and Andy's already done a great job in introducing it. I think the first thing that I really want to make sure people understand is that it's not just like serverless poly-based. So I'd previously worked with tools like AWS Athena, Google BigQuery, Dremio, and I sort of Synapse SQL Serverless came out and I was like, fantastic, this is just poly-based, serverless, great. But it actually does behave differently and there are different features and different capabilities that you need to be aware of. There is a very, very detailed white paper at aka.ms/synapsedqp that you can access. You can have a read of what the engine behind the scenes is, and we talk a lot about Polaris, if Mark or someone else has mentioned that before. I think it's just important to sort of reset some of your expectations because I think that becomes quite important as you start to explore the service. So, you know, when this first came out, I sort of said to myself, okay, I've used some of the competing technologies prior to working at Microsoft. Where are the best practices? And there's a whole heap of best practices that we put up on docs.microsoft. The problem with them is like some of them are obvious and some of them I'm like, well, how much? So, you know, the first one is like co-locate your storage in your serverless SQL pool. Okay, I get it. Latency is a concern. Don't put stuff in Australia and query it from Amsterdam. The second part is, you know, storage accounts have limits, so don't be doing too much stuff against a storage account at a single time. Once again, very straightforward and makes sense. The third one is, okay, let's use Parquet instead of CSV. That makes a lot of sense to me. You know, I think anybody who's used a lot of different file formats would be aware of that. But the question I always have is how much? You know, customers or in a prior life, I would always think, well, how much pre-processing should I be doing to move data into different formats? Like what's the actual substantive performance benefits that you're going to get out of it on this particular technology? The fourth one was, okay, let's query multiple smaller files, but keep them relatively uniform. But the problem is anybody who's used Databricks or Polybase even, or any of these sorts of technologies would be aware that, you know, you can't just have every single row in a single file and expect that you're going to get good performance. And you also start to lose some of the benefits of Parquet format itself. So my question is, well, what makes sense? The next one was, okay, target partitions and push your wildcards down to the lower paths. That makes sense, but, you know, once again, what's the benefit? And how do we make that look, you know, how do we make that seem like it's going to, sorry, let me try that again. How do we make sure that business users can actually use that in a meaningful way if they're writing SQL queries? Watch for inferred. I would question whether it's true inference, data types that are occurring within Synapse SQL. And then the external tables gives us a couple of different performance benefits. So using a storage account key can improve performance and statistics improve performance. Now I want to be really clear here. I'm not going to delve into the depths of statistics today. That is for another time and someone far smarter than me. So let's jump into the first part. Like, how does partitioning and file type affect performance? That's one of the big questions that I had. And are they different for different file formats? Because potentially you therefore need to know that when you're designing your ingestion processes or what, you know, whatever you're doing. So I've created a bit of a synthetic data set. I want to be very clear, this synthetic data set has a lot of caveats to it. So first of all, it's a synthetic IoT data set of 1,300 devices at a 15-second interval into IoT Hub and then into Stream Analytics. We're then writing that out on like a 2-minute window with a 2,000 row minimum write. That's generated over the last however long, 6,500 Parquet files. They're roughly about 1.2 megs each. So it all works out to be about 7.5 gigs worth of data. We're not talking big data here. But each device, so each IoT device, one of those 1,300s, has a device ID. And it also means that we've got relatively uniform data volumes across those different devices. And then what I wanted to do was take that data set and split it into multiple files and partitions, and I'm going to kind of use those terms interchangeably a bit during this session. That'll kind of hopefully make sense in a second. And then I'm basically running a fairly straightforward query over the top of it, a group by, an order by, and I'm going to run that 50 times. So that's what I've used to sort of test and come up with some of these findings. This is what those files look like. So, the CSV total file size obviously isn't going to change too much. Parquet files actually doesn't change very much either, but you can also see what does the average file size look like. So let's run those queries over the top of it. Now, all of this sort of takes time. So for part of this, you're going to have to believe me. And I'm trying to figure out a best way to sort of publish this, whether I publish a SQL notebook or something on top of this. So what you can see here is in the blue is the average query time for Parquet. In the orange is the CSV, depending on the number of files and partitions. Now, just to be clear, so that's number of files for CSVs, and then it's number of files and partitions for Parquet, because one Parquet file is like each Parquet file is per partition for the process that I've used to do this. So what you can see is a pretty, fairly interesting sort of view. So first of all, no surprises, pardon me, Parquet massively outperforms CSV. This is in milliseconds, about, you can figure out that about what that sort of means in normal time. And you can sort of start to see here that, first of all, Parquet well outperforms CSV. Also, you can start to see that, single files obviously does not perform very well, but Parquet actually, we're not seeing a huge difference in the amount of data, the amount of time taken to do it. And that's probably indicative of the sort of small data set that we've got that I'm using for this. So the next question though is, okay, these serverless products are all well and good, and most of the time they perform well. But if anybody's had experience with the competing products, you would know that, okay, the average isn't what you're worried about. What you're really worried about is the max time, because sometimes they just freak out and don't return you a response. So one of the questions that I had was, what does the max look like for Azure Synapse SQL Serverless? So what we can see here is the darker orange and the darker blue are the max times. And this really starts to show us that whilst the averages might be reasonable and you might be happy with that performance characteristic, you're certainly not going to be happy with that performance characteristic for like Power BI direct queries, right? So let's first of all say that's not okay. But if you're writing either queries into some sort of engine, or alternatively you're pulling it into Power BI in memory models, this performance is pretty good on the whole. The problem is that very often this max is more than twice the average. And so suddenly you've got a huge amount of variation in the query performance, even though it's running the exact same queries. There is no caching that occurs on SQL, on Synapse SQL Serverless. That's a real mouthful for me. So we still see huge amounts of variations. I did make sure that these weren't just first run queries or anything like that to ensure this. So what are the takeaways? First of all, Parquet performance is quite fast on 5, 10, 25 partitions or files. And I'm going to show what that looks like in terms of the file sizes in a second, because I think that's probably where the takeaway actually is. And CSV, on the other hand, actually is performing best on the 32 partitions, which I think is interesting because it also means that those file sizes potentially line up. So let's go back to the file sizes. What we see is that the fastest query time is for Parquet on average is coming from 340 meg files and 10 partitions. You can also start to see though that 5 and 25 are the 5 is pretty much double. That's actually exactly double. And you can see for CSV that that 360 odd megabyte file is being read pretty quickly. Sorry, megabyte files is being read pretty quickly. So I think this is a really interesting takeaway. The problem is, first of all, this data is not very big in the grand scheme of things. The second problem is it's sort of neatly shaped, right? It's fairly uniform data. And that might be the case in IoT scenarios, but if you're talking about, say, what Andy was talking about with dimensional modeling, you very rarely get neatly shaped data with simple queries where you've got a clear partition key candidate. So your mileage is going to vary. What I think probably is my big takeaway and big thing is that if you're running this, if you're thinking about running this in some sort of production workload where users are going to be dependent on it, you've really got to watch out for these maximum run times, because that might potentially violate things like timeouts for queries, or it might just create a crappy user experience, which means your users say the data warehouse is running slow. I'm going to grab some water. So that's pretty good. And that to me is quite interesting, but I think there's a lot of additional work that I've got to do to figure this out, or other people have got to do. The other part of it though, and Andy delved into this a little bit, is you're paying on the data, the amount of data scanned. So the time is not actually the factor in terms of how much it costs. What really is going to drive cost is how many terabytes of data you scanned. There's a 10 meg minimum, I think, from memory, but that sort of all works out. The thing that you can really start to see here is that the CSV format, because it's not like it's just a dumb text file, you get no benefit in terms of the cost. So if you've got users continuously hitting F5, which I know that I've done when I'm frustrated about the performance of something, hoping that maybe if I hit F5 10 more times, it'll run faster. But in Synapse SQL Serverless, you've got no caching. So users hitting F5 every time, particularly if it's against the CSV, potentially is going to end up with a huge amount of cost for you. Whereas on the Parquet format, particularly where if they're only asking for a couple of columns, and the query that I'm running is deliberately only asking for a couple of columns, you can see that the data actually being processed is absolutely minimal. And that then drives sort of lower costs. And you get the performance benefits as well. You can also do cost control. I'm not going to go into that in today's session, but there are options to prevent someone just continuously hitting F5, or trying to use Power BI direct query. So I've extracted all of this information from Sys direct queries. So what we can see here, if I jump into Azure Data Studio, and I hope that this loads, is that we've got a DMV here that we can actually use to extract this this data out. So there's the requests, which is fairly boring, but then we've also got the request history. Of course. Where you can start to see things like the status, transaction ID, who was running it. You can obviously then be figuring out the query hash, because you're going to get the query hash returned. You can see the total elapsed time. You can also see the data processed. So you're able to pull this information out through fairly standard DMVs. That makes life very easy. So the next sort of best practice that comes up is, okay, we can improve performance with the file path and the file name functions. So Andy also introduced these constructs. For those who weren't in his session, I get a recording of that. If he's going to put it up, that was pretty good. Or at least I think he's going to publish the slides, so have a look through that. But file name is a function that's going to return the actual file name. It says what it does on the box, and file path is going to return the file path. But file path with the number returns the relevant wildcard, and we can actually use that with views. So let's have a look. Let's jump into. I didn't get to use my GIF, but there you go. So file paths. I can, for those who haven't seen this yet, maybe you're late joining or it's a different time zone, I can, from the Synapse experience, navigate to a Parquet file or a CSV file. I can click here and I can click run this query. It's going to basically grab that file. It's going to query it. It's going to, particularly for Parquet, it's obviously going to figure out the data types for you, figure out the column names and all that sort of stuff. You can change the parameters on the CSV parser to read the first line as headers. That's quite simple to do. So, okay, that's all well and good. I can do this. Now I'm going to jump back over to Azure Data Studio. So first of all, there's nothing about Synapse On Demand that looks different from an MS SQL point of view, from like an API protocol perspective. So you can use Azure Data Studio. That's what I'm going to use for most of my demos. You can use SMS, which I'll also use a little bit later, but you can also use other tools like Power BI and whatever. So what I can do here is I can go result dot file path, and I can click run. Okay, well, that would have been nice had it have worked. I think if I get rid of the star. No, all right. That's all well and good, but fortunately, I've got stuff that I've prepared in advance where I haven't made a boo-boo like I clearly have there. So I can, on top of this, start to read in each of these parameters. So I can read the file name, I can read the file path, and what I'm doing is I'm defining this one number here is what's actually defining against the first asterisk that it finds, the first wildcard that it finds. So the first wildcard here equals year, the second one is month, third one is day, fourth one is hour, and I can continue to do this as needed. And what that means is that I can start to pull out a whole heap of that information through here. And you'll notice that I've added these columns. Let me get rid of that for you. So, these are columns added here, and you can see that I'm pulling out the file name, I'm pulling out the file path, and I'm pulling these all out as individual objects. So it's coming through into the query. So that's useful to be able to figure out exactly where your file is. But one of the things that users are often going to do, and I'm not going to run this query, I'm not going to try and run this query because some of these queries take a couple of minutes, and I don't want to bore people's brains out with just running a boring query like this, is users will often say, for example, on this sort of IoT data set, they'll be wanting to pull through data for just a particular day. Now in this version, I'm just pulling through a straight query on top of it. That takes about 1 minute 50. I've commented out that time, that time part of the where clause, so it's not going to run, obviously, and that takes 1 minute 50. But what if a user And this is a fairly common scenario. Users looking through data of some description, and they actually want to search for a particular time, a date, like in this case, a date, on top of that time field is actually a date time field. They can do that, right? They could just pass through and they could go, all right, query, time is, in this case, the 20th of January. Well, they can do that. The problem with that is that this query here is not very smart, and it's not actually going to be able to read these wildcards and eliminate these wildcards because we're just defining it against a field inside the Parquet file. So it's going to have to read through each of those Parquet files to figure out what you actually want from it. And therefore you can see that we're processing a fair bit of data. Okay, so that's like what users are going to be doing when they're trying to query this data set. But what if we want to make our users a little bit more intelligent, or more importantly, we want to protect them and protect our budgets from themselves? So what we can start to do is we can run queries like this. Now you'll see that the difference here, and I can run this one because it's relatively quick, is that I'm defining each of these file paths. So I'm defining file path 1, which is mapped to the year wildcard. So let me zoom in. So you can see that the first one is here, second one is here, third one is here. And I'm defining that 2021, 01, and 20. Now, you'll notice that at the moment, these are just varchars, like that. They're just being inferred as varchars 8000 from memory. So, there is a little bit of data typing concern that we've got there that we would probably ideally want to work with. And what you can see is, first of all, that query took 12 seconds as opposed to sort of 4 minutes. But we can also see that the data scanned becomes a lot lower. So yes, data scanned has some relevance to how long queries are going to take within reason. But the other part of it is data scanned is what's driving your money. So whereas, when we talk about like SQL Server optimization, some people will talk about like query bucks. The great thing about Synapse SQL Serverless is you've literally got query bucks, and unoptimized queries will cost you, money. Makes it easier to prove your worth. But what happens if we put a view over the top of this, right? So we can create a view over the top of an open row set function. That's really easy. You can just do a select star as, blah, and go from there. But we could also then define fields in that view as these file paths. So the question becomes, will SQL be smart enough to figure that out? Will the engine behind Synapse SQL Serverless figure that out and do the more efficient operation, which is to read all of these onto the file paths and then run that? And the answer obviously is yes, because I wouldn't be running this. It's a bit of a useless experiment if the answer was no. So what this means though, is we can create views over the top of open row set functions that enable business users to be able to query SQL in a way that they are much more used to. Year equals this, month equals this, day equals this. And obviously, if I was doing this in production, I'd make sure that I'm casting these fields appropriately so that users are a bit more comfortable with it. So it's a great solution for those users who want to be able to flexibly query something, but maybe their SQL skills are not, fantastic. They're coming from much more of a business-oriented view, and they know enough SQL to get by. They don't have to change the way they're thinking in order to do some of this. So that was the demo, the first demo. So file name returns the file name, file path returns the file path with the number is going to do the wildcard stuff. We've got to watch for data types, and it can be used with views very efficiently so that engines like Power BI can be picking that up as well. Okay, so if we move on to the second, one of the other best practices was around, you've got to be careful about data typing. there's parts of the documentation that say that the schema is inferred. That's a lie. There's static mapping between Parquet types and SQL types. And when there is a string type in Parquet, it gets generally typed to a varchar 8000. It kind of actually depends on your collation, but for all intents and purposes, most of the time it's going to get driven to varchar 8000. And of course, the problem with that is, varchar 8000 isn't very efficient. So what we can start to do is we can start to, actually see what's going to get read by a particular query. And so there's a stored procedure in Synapse SQL Serverless. You'd think I'd know the name of the product by now, that I can actually describe what data set I'm going to get. Now, if I do that, so it's fun. So it's going to take this file and it's going to tell me how's it all getting described. So it's pretty lazy, right? So I've got a field called events, which is only really small int. So there's no reason for it to be a big int. A lot of these probably do need to be floats. They're, fairly precise decimals. Though I could recast them obviously, but this, connection device ID is being cast as a varchar 8000. And that's not very useful for me, particularly if I'm, as I am doing, I'm continuously running group bys on top of this field. This field is nowhere near varchar 8000. It's a random string, like if I show you what it is. The fun fact of using that stored procedure is you do need to escape some quotes. Yep, there we go. And so you can see right over here that there's a, basically GUID with some descriptors on top of it, which is defining the connection ID. So that does not need to be varchar 8000. So obviously, if you're doing joins, which I am doing a group by, but I don't think that's creating too much of an adverse performance. You really do want to be checking what are these being cast with. And in the open row set function, you can use a with function as you would with an external table or anything to more precisely define the schema, so that you can try and create some efficiencies on top of this, on top of data typing, because data typing is still going to be an ongoing concern. So that's data typing. This data set doesn't really suit showing what sort of performance benefits we can get over the top of that. Okay, let's then talk about external tables. So within Synapse SQL Serverless, we've got both the idea of views that leverage the open row set functionality, and we've got external tables. And so you might be thinking, what's the difference? Well, is there a difference from a security point of view? Not really. Both can support using shared access signatures where the user credential is not actually being passed through to the data lake, but rather it is defined in the schema. The big difference, though, comes in because statistics are supported with external tables, whereas they're not supported with open row sets. Once again, as I said, I'm not a I'm far from a statistics expert, but obviously that gives you a lot of benefits, particularly on your joins. The big areas that you've got to be mindful of, though, is, and this is true of any sort of data lake architecture, is you can be changing the data underneath the covers, right? And so those statistics can be very quickly completely and utterly out of date. Now, Synapse SQL Serverless has an option for recreating statistics for Parquet files, but it does not support it does not do so in the same way for CSVs. And if you manually create statistics, you've got to manually update them. And so that raises a big question around, if you're going to be defining through external tables, and you're going to be wanting to be doing views on top of the data. External tables probably do make sense because you can have the benefit of the statistics. But second of all, you want to be careful about how you're updating your queries. So if you're using a data flow or something to push data into your data lake, you might then need a step to recreate, update statistics or something like that to ensure that you don't end up in a situation where your queries are running with completely out of date statistics, because you're going to potentially get actually performance degradation rather than being in a blind situation. So let's take a look at external tables. So so this is the most efficient open row set based on the sort of performance stuff that I've got, keeping in mind that we could run into a situation where we're ending up with the max instead of the min. So that's pretty fast, 5 seconds, it's coming back. So let's put an external table over the top of this. So I'm going to drop the external table that used to work here. So the first type of external table that I can create is where my credential is being passed through to the data lake. And that's what's happening here, right? I am just passing through my credentials, Lou Malone at Microsoft.com is going to be passed through to this ADLS. And that's the default that comes out of Synapse. So, this is the code, right? Still keeping the inefficient char 8000, but I can also do that directly from here. So I can just go create external table, and I can go, and it's going to create this. You can do automatically. I kind of, the purpose of this will show you what gets outputted. It puts it all out for you. You can then also start to play around with the wildcards and whatnot to ensure that you've got the data that you need. So you can go ahead, do this. It's going to write this statement for you. If you're anything like me, that's really beneficial because I hate writing these statements. I'd rather something else writes it for me, and then I'll just, fix it. But I'm going to go back to Azure Data Studio. So I can run this. And it's going to hopefully run. If you haven't used Azure Data Studio, by the way, SQL Notebooks is great for sort of demonstrations or this sort of stuff because you can really sort of show each step in sequence. And it supports things like Go, very neatly, and Go 50 or whatever. So it's it's a tool worthwhile knowing about. And then I can run this query. So now I'm referring to the external table. So I'm not having the open row set. I'm not referring to the open row set view, and I can run that. In my testing, the performance benefit is not massive, but once again, there's a lot of limitations to the data volumes that I've seen, that I've done. What we can also do, how I was talking about how statistics are going to be created, we can actually go in here. And this is a view that is published on top of, this view SQL schema is defined in the docs, so you can easily get it. I'm happy to post it somewhere if you're unsure, but it's just going to pull through the stats and try and clean this up a little bit for you. And you can start to see that there's a stats query. You can also see that that's been updated a couple of minutes ago, or a minute ago. But what if I want to give users access to the data, but I don't want them to actually have access to the data lake? And potentially, I want to define a schema for them that's already pre-configured, so they can't do anything stupid with the varchar 8000 or whatever, but also maybe I only want to limit them to certain rows. Now, you should be careful about doing that and using that as a security boundary. But what you can be doing is, instead of passing through the Azure Active Directory user to the ADLS Gen 2 endpoint, you can instead be defining it through a shared access signature. And you can generate a shared access signature very easily from the Azure portal. I have obviously decided to get rid of my shared access signature from here. So I previously run this statement because obviously it would create an error for me. And I can do this. Now I've created this one previously, table 1. And what this means now is that I've defined this table with a security definition, with a shared access signature. So it's got the capabilities to access that data, read that data, and interact with that data. And then I can obviously run queries on top of it. Now, in my testing, once again, it's a small test, blah, 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 blah. There's a lot of disclaimers to it. I haven't seen a huge performance difference between the two, but my understanding, the documentation certainly shows, and I've seen situations where if you've got large data being queried, using the Azure AD pass-through does create a performance concern. So obviously that becomes something that you want to test if you're doing large data volume transformations. It also potentially works really well for certain enterprise IT environments, or alternatively breaks all of your enterprise IT rules, depending on how you feel. So, okay, but so I keep talking about that we've got a, different, like users can then access that data without having access on the data lake. Now I am logged into SSMS. So I'm switching interfaces, hopefully, because that'll make the experience clearer. And I am just logged in as my SA user because, that's what everybody should do all the time. And you can see right here, this user does not exist in Azure Active Directory. It cannot be given access to certain things. So what happens if I try and run some of the things that I've created? So let's have a look first of all at the view that I created. Now this view was open row set, no shared access signature defined. Am I being passed through the wrong user? That is interesting because I wouldn't have thought that should have worked, but anyway. Let's see whether this part works. So the external table where I'm passing through the Azure Active Directory user, where I haven't specified the shared access signature, I'm getting no access because the content of the directory, as in the directory on the ADLS Gen 2 account, can't be accessed, cannot be listed because SQL admin user, who the hell are you? Whereas on the flip side, if I go to the external shared access signature table, I can run that because that table actually defines how to access the ADLS Gen 2 account and defines credentials inside that external table. And so that, that also does open up different possibilities in terms of not giving users necessarily access to the data lake, but defining their access in a SQL environment. And that might be easier for you. It might be simpler. It might just be easier to meet your particular security restrictions or requirements that you've got as a company. So what we can see from that is that we can define external tables on top of Synapse SQL Serverless, and we can kind of progress from there. The stats, which yes, I did show, also introduce an added benefit, but they're also a little bit of a double-edged sword, particularly if you're manually creating the statistics, because they won't get updated and the data under the covers can change very easily. So always be careful about statistics. So what are some conclusions? First of all, Parquet improves performance and saves money by a fair bit. It certainly saves you a lot of money in this scenario, if you're doing this a lot, obviously. So that's fairly obvious, but it's interesting to see that it's that big, and also that because of the way the data gets scanned and processed, the difference becomes very apparent on a financial end, particularly if you've got annoying users hitting F5 or putting Go 50 on something. File name and file path can be used to improve performance and can effectively be hidden in a view. In that situation, the view does require access to the files, but you could also alternatively be creating a view where you've got a shared access signature. So you don't always have to have open row set, meaning that users have access to the data lake, because you can use shared access signatures. External tables work well for users without access to the lake, particularly because it comes through very neatly for them, particularly into some tools, and you can kind of manage their experience a little bit better from a statistics point of view, where users otherwise might be a bit surprised at the performance. External tables semi-automatically create statistics and behave differently between file formats. So Parquet automatically create the statistics on select statement and will recreate, but that leads to other concerns. On the flip side, CSV, basically it's up to your own your own processes. Final thing is there are severe limitations on what I've on some of the stuff that I've said, because different data sets are going to perform differently. And I think that's probably one of the big takeaways that I'd have for all of these on-demand query engines is you have to test this. If you are wanting to put this in production, make sure you test with a production-like workload, because that will be the main way that you know what the performance is going to be like. It's also going to enable you to know not just what the average query performance is going to be like, but that 99th percentile query performance is going to be like. And I would think that most organizations that have robust testing processes are often monitoring that 99th percentile to ensure that they're meeting the expectations of their users. Otherwise, you might need to look at something where you've got a bit more control over the resources. SQL dedicated pools are probably where you're going to end up then. So we've got a bit of time for questions, so I'm happy to take some questions if there are any.